Greetings, mathies, mathematicians. We're your calculus students now. Grab your calculator. We're going to look at how to graph derivatives. First in kind of a simple way, and then a little more complicated way if you're given less information. So I don't want you to lose sight of the fact that a derivative is just the slope. Don't get scared by scary sounding names. So if we're trying to graph this, first we'll do it with all the tech we can use, just to see how it would look. And then we'll back off and use just the graph, and then we'll back off and use just the equation. So we have all the tools right now. Let's put this equation into your TI, your fancy TI. So go y equals, I put x cubed minus 7x plus 6, and a hit graph. You do this too, because you need to be polished at fighting through this. I can't see all of my graphs, so I might add a little bit to the window. I want to go see more of the y value, so I might bring that up to like 15 or something. All right, maybe make this -5. Don't hit the minus button, hit the negative button. Yeah, looks a little better. Okay, fine, whatever. Just I want to be able to center it. A neat trick that I don't know if you've seen yet in the videos is that, yes, you can say second calc and ask for a value and put in a value of, I don't know, 4. And, oh, too high. Let's try another one. How about 3? And it gives you 12, right? It's right there. So you go over 1, 2, 3, and you'd go up, and so we'd be at 12 right there, right? Not surprising. That's nice, but did you see what else is in there? If you go second, and so that gives you a location in space. If you go second and go there, look at this thing. dy dx, it'll tell you the derivative. It won't give you the equation. It'll tell you the slope at any point you want. So go down to 6 or hit the number 6. And if I want the slope, well, yeah, let's look at the slope like here at -1.528. So go -1.528. Hit enter. It tells you a location in space, -1.528, and the y value. But above it, it gives you the slope. And that slope is pretty close to 0. Why? Because that's pretty close to a maximum, and the slope up to there is 0. If you try this point, if you put in 0, you don't have to go back through it, but you can go second, calc again, go down to 6. If we put in 0 for the x value, it tells me y equals 6, that's the location, but also it tells me this number, about -7. That means the slope here is -7, rise -7, run 1, and that looks about right. If you look over here at -3, you can just punch in -3. Oh, quack. Second calc, 6. If you second calc, 6. If you punch in -3, it tells me the location -3, 0, which I know, but it also tells me the slope is 20, and that looks about right, like we're going up really aggressively here. So what we're going to do is just do something very simple and build a table of values using this idea. So I already know that at -3, the slope, so let's go -3, the slope is 20. Let's just keep going. Let's go -2, -1. I'm gonna go -1.528, -1, because I know that's an interesting spot. So now just connect the dots. Ba-boom, 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 ba-boom. there's your derivative. That's the easiest way to run it. It's super clunky, and there's a way, like, all of this makes sense also if you look at it right. So here is x cubed. What do we have? X cubed 7. Got a couple of these up. So this is that graph, right? If we look at the derivative, it looks like that, like we expected, this big U shape. And we're not that surprised, because if you zoom in on this a little bit just so we can see the pieces, you can kind of infer what's happening. I know that here on the blue curve, the slope here is 0, and that's why the derivative crosses the axis right there. Similarly, so that where you get these maxima and minima, you should have your derivative crossing the x-axis. Similarly here, the derivative is crossing the x-axis. Here is between the maximum and minimum, this is like the most aggressive downhill, would be like right in there. If you were skiing, this point's not bad to ski, and this point down here on the blue, where you're slowing down, but right in the middle is the most aggressive. This is the most downhill, the steepest. So it has the largest negative value there. And so this point corresponds to a minimum on the derivative, right? A little bit hard to digest all of those pieces. So let's take that and try to do it without graphing this, right? So let's get rid of this thing just for a second. And we're going to sketch just based on this. Now, I don't know what this curve is. I don't know the equation for it. I don't really care. But I know a couple of things. The slope here is 0. So just looking at these, if I'm trying to graph this, I'm going to graph it right on top of this. The slope there is 0, so that the derivative value should be 0 there. Similarly, right here, maybe not at 2, but right here it looks like there's another 0. And right here it looks like there's another 0 for the slope. 0 slope at those spots. Now, this looks like it has positive slope. I'd be climbing uphill. So this is going to have a, I can't exactly see what the slope is there, but I know it's going to be a positive value. So right here at time 0, when you put your skis on, you have to start walking uphill. So that's a positive slope. I'm going to just put 3, like sketch it. If they really need you to know where it is, if it's 3 or 5 or who cares, they'd have to tell you some more information, maybe give you some values. But right now I'm just kind of guessing, right? So rough shape. I know that the slope goes downhill, like this gets progressively less steep. It's harder to walk here and easier to walk here. So the slope goes downhill. Make a nice curve. It's not a straight line, right? And then the slope, now the slope starts going downhill, so the slope becomes negative, right? And somewhere between here and here, it bottoms out and comes back up to 0, right? It's always negative. You're always going downhill from here to here. So this is going to be like going downhill. It gets most aggressive. You have the fastest ski run right here. Here, not very steep. Here also, not very steep. Still negative, but not very steep. So it goes not so steep, gets really steep, and less steep. So negative, most negative, less negative, but still negative. Right? So bottoms out right under, like this point looks the steepest. So that would be the lowest spot. Comes back to 0, because right here, again, 0 slope. And then it starts going positive again. Positive slope. How much? I don't really know. We don't have any values on this, but this part is more steep than this part. So this height should be bigger than whatever our height should be here. Right? A little bit hard to see that, but because this slope, even though it's positive, it's more gradual than this slope. So this slope is rise over run, making stuff up -3. And so this should be 3 down. This value, so many lines. Rid of that for a second. This slope between here and here, this is the highest point. This would be hardest to climb here. Easiest to climb here, easiest to climb here. Hardest to climb there. This slope, rise over run, is not the same as this rise over run. It's more gradual. Right? It might be like 1. So it won't go down as far. This goes 3 units down. This green curve is going to go one of those units up, right? So it'll kind of be more gradual. Here the slope's 0 again, so it comes down and touches. And then after, the slope goes negative, and we don't care anymore. Cool. Now, this is the actual graph of the derivative. Ta-da! Now, how far down this goes? They didn't give us enough information. But note that my down here is larger than my up here. And similarly, let's bring this down so you can see it better. This should be larger than this, right? And we're just sketching these, right? Sketch. If you need exactly, you grab your calculator. All right, so let's have you try that. Here's a graph. Give me a sketch and tell me about some of the points. All right. This shows, I guess it goes backwards, huh? This shows the derivative. Can we graph the original? Okay, I know that the zeros are here and here. So that denotes a maximum or minimum. This thing goes like this and tops out there, bottoms out there, or vice versa, right? And I don't exactly know what that looks like. However, I do know, oh, and here. So it goes max, min, max, something like that with some connections, or vice versa. And I don't know unless we infer some other things. Between here and here, if this is slope, all of these are positive values. So between here and here, these are positive slope values. So if they're positive slope, they're pointing uphill. Yeah? And the slope goes maximum in the middle and then comes back down to 0. So if you have positive slope and it gets the steepest, we want to draw this. Let's just sketch some things out. So let's pretend this is a maximum, a minimum, and a maximum. This says I have positive slope from between these two. And if this is a maximum, between this maximum and this minimum, to go from max to min, I have to go downhill. So all of that's a negative slope. And this says that we have positive slope, so it can't be that way. It's got to be the opposite way around. So I think we start with that minimum. So let's try that again. Right. So there's my zeros for the slope. So I think we'd have to start with a minimum, go to a maximum, and then back to a minimum. Exactly where they are, I'm not really sure at the moment, right? And so let's see. This makes more sense because here our slope 0, here our slope 0, and all the way through here, each of these points denotes a slope of the original red line that I'm trying to draw. The slopes are all positive because they're above the x-axis, and that kind of makes sense because all of these are pointing uphill. Similarly, after this site of a 0 slope, it looks like my slopes are negative, and that makes sense going from maximum to minimum because they're all going downhill. Yeah. And then it switches over at this point and aims uphill again. So I think it's going to look something like that. So let's see what they say. Cool. We looked, I mean, roughly, it looks like that. Where is this exactly? We don't know. Right? We don't have enough information at this point because they just told us some very rough points. Right? You could build a sign diagram to help you with that, and that's what we'll do in the next piece from here.